Hi, this is again problem 46 in chapter 3 of Donnelly's second edition. It's the same problem. We have x and y values that have been given to us, and we need to compute covariance right here, sample correlation coefficient, and in doing so we need the standard deviation. So I will show you first that you can solve this problem with the function covariance. So you can set equal to in an empty cell. You can put equals covar, and then you can see that it pops up. This is a sample. This is sample data, so we need sample covariance. So covariance S. Let me do this in another cell where we don't have anything to cover it up. Equals covariance, and I want the sample covariance, and then I need to identify the two array. So here is x values and here's y values, and at this point you get 2.75, which is what we computed when I showed you manual calculations. But let's see that how we can use formulas in Excel to accomplish the same thing. So x minus x bar, we need x bar values. So let's go ahead and compute x and y. Let me move these down here a little bit. So okay, so we need mean values or average values. Okay, so we need equals average of these x values, and I can copy that over, and now we have the average for the y values. So the first order of business is to compute x minus x bar columns, which is equal to this value minus this value, but I want to fix the cell reference here, so I will put the dollar signs, and at this point I can copy this down. You can do the same thing for y values. So that first y value minus its mean, I'm going to fix the cell reference and then copy this down, and we are there. The next thing is we need to compute the product of, or multiply this column by this column. Each value multiplied by its corresponding value and record it here. So what we need is put equal to D2 times E2, which is -1 times -2 equals 2. At this point I can copy it all down, and then notice that we need to have the summation of those products. So over here I need to put equals to sum of all of this, which is 11. Now in order to compute the covariance, what we can do is take that 11. So we have covariance, so S of let me format cells and go subscript. So the S of xy okay, so the covariance of x and y is equal to 11 divided by n minus 1, which in this case is 4. So covariance is equal to 11 divided by 4, which is 2.75. Now to compute sample correlation coefficient, notice in the denominator we must compute the standard deviation for x and also the standard deviation for y. So if you wanted to write formulas, you would have to take each x value and subtract from it its mean, and that difference needs to be squared. Now notice that we already have the x minus x bar column computed. That's this column right here. So each of these entries in this column need to be squared. So this I write as equal to this value squared. And so -1 squared is 1. And I can copy that down. The same thing, this will be the y minus y bar, or this -2, that will be squared. And then I can copy that down. So the sum. So in order to compute the standard deviation for x, I can either do standard deviation or sample standard deviation for x to be these values right here, which is 2, and sample standard deviation for y is equal to standard deviation of sample for y is equal to these values. So that's also 2, just like in the previous video that I computed. And so now I have enough information that I can compute covariance if I wanted to write formulas. So covariance is equal to, I'm sorry, correlation coefficient. Correlation coefficient is covariance, which is this 2.75, divided by the multiplication of, or the product of, this number times this number. And if I were to show more digits, you can see that it's 0.6, oh, more digits, 0.6875, which is what we computed with the with hand calculations. And again, like I said, you can write covariance of sample data and just give it the values separated by a comma here, separated by a comma, and then give it the second array, or the y array. And at this point, if I hit enter, I get the 2.75, which is the covariance. I can compute the correlation coefficient also. So this right here is covariance. And I can compute correlation coefficient as equal to correl of this column and this column. And you can see the 0.6875. This is the correlation coefficient. The next video will show you how to compute standard deviation. It will show you how to compute standard deviation for for each of these variables. Just the standard deviation. With this calculator, you cannot, there is no function to compute coefficient, covariance. But I can show you how to compute correlation coefficient, and also I can show you how to compute the standard deviation of a single variable. So the next video will be that.